Welcome back to Sleep and Universe. Tonight, we journey to some of the most beautiful places in all of existence, places where stars are born, where dying stars paint the cosmos with brilliant colors. Tonight, we explore nebulas, the universe's most magnificent clouds. Get comfortable, close your eyes, and let your mind drift into the colorful tapestry of deep space. Pause. Scattered throughout the darkness of space are vast clouds of gas and dust. These cosmic clouds glow with ethereal light, painting the universe in shades of crimson, sapphire, emerald, and gold. These are nebulas. The word nebula comes from the Latin word for cloud or mist, and that is exactly what they are: enormous clouds floating in the space between stars. Some are small, just a few light years across. Others span hundreds of light years, containing enough material to create thousands of stars. Nebulas are made primarily of hydrogen, the simplest and most abundant element in the universe. Mixed with the hydrogen are traces of helium and heavier elements: oxygen, carbon, nitrogen. Elements forged in the hearts of ancient stars and scattered into space. The dust mixed with the gas is incredibly fine. Tiny particles, smaller than smoke, made of carbon, silicon, and iron. This dust plays a crucial role in star formation, helping gas clouds collapse under their own gravity. When you look at a nebula through a powerful telescope, you are not seeing solid objects. You are seeing gas so thin that on Earth we would call it a vacuum. Yet these clouds are so vast that they contain more mass than thousands of stars combined. Nebulas come in many different types. Some glow with their own light, energized by nearby stars. Others shine by reflecting starlight like cosmic mirrors. Some are dark, blocking the light of stars behind them, appearing as dark patches against the brightness of the Milky Way. Each nebula tells a story of birth, life, and death among the stars, a story painted in light across the cosmic canvas. The most colorful nebulas in space are called emission nebulas. These cosmic clouds glow with their own light, like celestial lanterns floating in the darkness. Emission nebulas shine because they contain young, hot stars. These stars are incredibly luminous, pouring out vast amounts of ultraviolet radiation. This intense radiation energizes the surrounding gas, causing it to glow. When ultraviolet light strikes a hydrogen atom, it strips away the electron, ionizing the atom. When the electron recombines with the hydrogen, it releases energy in the form of visible light. Specifically, it releases a deep red light. This is why so many nebulas appear crimson or pink. But nebulas contain more than just hydrogen. Oxygen, when energized, glows green and blue. Sulfur glows red. Nitrogen glows reddish-orange. These elements combine to create the magnificent colors we see in nebula photographs. The colors in nebula images are often enhanced to show details invisible to the human eye. But the colors are real. They represent different elements, different temperatures, different processes occurring within the cloud. One of the most famous emission nebulas is the Orion Nebula. Located in the constellation Orion, about 1,300 light-years from Earth, it is visible to the naked eye as a fuzzy patch in Orion's sword. Through a telescope, it reveals itself as a vast stellar nursery, glowing pink and red, where new stars are being born. The Orion Nebula is relatively close and incredibly active. Deep within its core, 4 massive young stars called the trapezium illuminate the surrounding gas. These stars are less than 1 million years old, mere infants in cosmic terms. Emission nebulas are stellar nurseries. The same processes that make them glow are also triggering the collapse of dense regions within the cloud. These collapsing regions will eventually become new stars. In this way, nebulas are both beautifully luminous and incredibly creative, constantly giving birth to new generations of stars. Some emission nebulas are shaped by powerful stellar winds and radiation. The gas is sculpted into intricate structures, pillars, bubbles, filaments. Each shape tells a story of the forces at work within the nebula. Not all nebulas generate their own light. Some simply reflect the light of nearby stars, like clouds illuminated by moonlight on Earth. These are called reflection nebulas. Reflection nebulas appear blue. This is for the same reason Earth's sky appears blue. The tiny dust particles in the nebula scatter blue light more efficiently than red light. So when starlight passes through the dust, the blue wavelengths are scattered in all directions, creating a soft blue glow. One famous example is the nebulosity surrounding the Pleiades star cluster. The young, hot stars of the Pleiades are surrounded by a faint blue haze, remnants of the cloud from which they formed. The stars illuminate this cosmic dust, creating delicate blue wisps that seem to swirl around them. Reflection. Nebulas are often found near young stars. The stars have recently formed, and the surrounding cloud has not yet fully dispersed. The nebula is what remains of the stellar nursery, now lit from within by the very stars it helped create. Then there are the dark nebulas. These clouds do not glow or reflect light. Instead, they block it. They are so dense with dust that they prevent light from background stars from reaching us. Against the brightness of the Milky Way, they appear as dark patches, like ink stains on a glowing canvas. The most famous dark nebula is the Horsehead Nebula. Located near the bright star Alnitak in Orion's belt, it appears as a dark silhouette shaped remarkably like a horse's head. This shape is created by a dense cloud of dust and gas that blocks the light from the glowing Emission nebula behind it. Dark nebulas are cold, very cold. Temperatures within these clouds can drop to just a few degrees above absolute zero. This extreme cold allows molecules to form and survive. Complex organic molecules have been discovered in dark nebulas, the building blocks of chemistry and potentially of life. These dark clouds are also stellar nurseries. Deep within their shadowy cores, gravity is pulling material together. Eventually, these dense cores will collapse, heating up and igniting nuclear fusion. A new star will be born, and the darkness will give way to light. Despite their name, planetary nebulas have nothing to do with planets. They are the beautiful, glowing shells of gas expelled by dying stars. When early astronomers first observed these objects through small telescopes, they appeared round and planet-like. The name stuck, even though we now know they are something entirely different. Planetary nebulas form when stars like our Sun reach the end of their lives. After billions of years of fusing hydrogen into helium, the star runs out of fuel. Its core contracts, while its outer layers expand outward, growing into a red giant. Eventually, the star's outer layers are gently puffed off into space. The hot, exposed core of the star, now a white dwarf, illuminates this expanding shell of gas. The gas glows brilliantly, creating the planetary nebula. Planetary nebulas come in astonishing variety. Some are perfect spheres, others form rings or hourglasses. Some display intricate structures with multiple shells and jets. The ring nebula in the constellation. Lyra is one of the most famous. It appears as a nearly perfect smoke ring in space, glowing blue and green on the outside with a fainter red interior. At its center, sits the dying star that created it, now a tiny white dwarf. Another stunning example is the Helix Nebula, sometimes called the Eye of God. It is one of the closest planetary nebulas to Earth, about 700 light-years away. From our perspective, it appears nearly face-on, creating a striking resemblance to a cosmic eye staring back at us. The colors of planetary nebulas tell us about their composition and temperature. Red indicates hydrogen and nitrogen. Green indicates oxygen. Blue indicates helium and very hot oxygen. These nebulas are fleeting. They last only a few tens of thousands of years before dispersing into space. In cosmic terms, that is the blink of an eye. We are fortunate to witness these beautiful final breaths of dying stars. The material expelled by planetary nebulas enriches the interstellar medium. It contains heavier elements created inside the star during its lifetime. This enriched gas will eventually be incorporated into new nebulas, new stars, new planets. In this way, planetary nebulas are part of the cosmic cycle of death and rebirth. When massive stars die, they do not go gently. They explode, and the remnants of these catastrophic explosions create some of the most spectacular nebulas in the universe. These are supernova remnants, expanding shells of gas and dust, racing outward at millions of miles per hour, glowing with the energy of the explosion that created them. The most famous supernova remnant is the Crab Nebula. In the year 1054, Chinese astronomers recorded a new star appearing in the sky, so bright it was visible during the day for weeks. What they witnessed was a supernova explosion. Today, nearly 1,000 years later, we can see the expanding remains of that explosion. The Crab Nebula is a chaotic tangle of glowing filaments, expanding at over 3 million miles per hour. At its center lies a pulsar, a rapidly spinning neutron star, the crushed core of the star that exploded. Supernova remnants are incredibly important. The explosion creates and scatters heavy elements into space: gold, silver, iron, uranium. All the elements heavier than iron are created in supernova explosions. The atoms in your body, the iron in your blood, were forged in the heart of an exploding star billions of years ago. Another breathtaking nebula is the Eagle Nebula, home to the famous pillars of creation. These towering columns of gas and dust stretch over 4 light-years tall. They are stellar nurseries, where new stars are forming within dense pockets of material. The pillars of creation are being eroded by intense radiation from nearby young stars. They are slowly evaporating, revealing the infant stars hidden within. These pillars are a snapshot of star formation in action. The Horsehead Nebula, the Lagoon Nebula, the Trifid Nebula. Each has its own character, its own story. Each is a work of natural art, sculpted by the fundamental forces of the universe. When we look at nebulas, we are seeing the life cycle of matter in the cosmos. Gas clouds collapse to form stars. Stars shine for millions or billions of years. They die, returning their material to space. And from that enriched material, new clouds form, new stars are born, and the cycle continues. Nebulas remind us that the universe is not just vast and ancient. It is also beautiful, beyond imagination. Every nebula is unique. Every cloud has been shaped by different stars, different forces, different histories. No two are exactly alike. The universe is an artist, and nebulas are its masterpieces, painted in light and color across the canvas of space. The images we see from telescopes like Hubble and the James Webb Space Telescope reveal details invisible to our eyes. Structures within structures, layers of complexity, delicate filaments and bold swaths of color. Each image is a revelation, a new perspective on the creative power of nature. These cosmic clouds are also deeply connected to us. The atoms in our bodies were once part of a nebula. Carbon, oxygen, nitrogen, all created in stars, scattered by supernovas, incorporated into new nebulas, and eventually gathered together to form our solar system and everything in it. We are, quite literally, made of stardust, and nebulas are the places where that stardust gathers and transforms, where matter transitions from cloud to star to planet to life. Looking at a nebula is like looking at a painting in a gallery. But this is a gallery millions of light years wide, and the paintings are made of real matter, glowing with real energy, evolving over millions of years. Nebulas are places of transformation. They are the maternity wards of the galaxy, where stars are born. They are the monuments to dead stars, glowing memorials to stellar lives long ended. They are laboratories where chemistry happens on an unimaginable scale, and they are beautiful, simply, profoundly beautiful. Pause. As we conclude our journey through the cosmic clouds, let the colors and wonders of these celestial artworks fill your mind. Let the gentle glow of distant nebulas carry you into peaceful, restorative sleep. Thank you for exploring the universe's beauty with me tonight. May you dream in colors as vivid as the nebulas themselves. Sweet dreams and clear skies. Until next time, this is Sleep and Universe.